Okay, let's dive into this. Welcome to today's explainer, where we're tackling a massive, high-stakes scenario. Picture this. You've got a restricted processing room. Inside, there are 100 Windows 10 and 11 computers, all powered up, wired to a controlled network, and ready for disposition. Your mission: securely inventory, erase, and generate cryptographically signed compliance reports for every single machine before they head off to a refurbisher. The stakes here, absolutely massive. Just one slip-up can lead to a data breach or a totally failed audit. So today, we're going to walk through exactly how you deploy and operate CyVectors DataDiscard version 5.7.0 to pull this off flawlessly, securely, and at some serious scale.
All right, here is our roadmap. We'll prep the physical processing room, configure the central console, and create our bootable erasure media. After that, we'll connect the agents and disks, execute the secure erasure jobs, and finally, generate those verified compliance reports. Staring down 100 machines sounds a bit daunting, I know, but breaking it down into these manageable phases makes the whole thing totally achievable.
Before we touch any hardware, let's quickly define the data discard ecosystem we're working with. Your command center is the browser-based central console, usually running on a dedicated secure laptop. Out on the floor, the Windows endpoint agent runs on the target computers. And for those tricky system disks, we'll use a bootable WinPE USB, the signed WinPE worker, and specific storage adapters. Now, from a pure security standpoint, here's what you really need to know. The agent only initiates outbound HTTPS and secure socket I/O connections to the console. There is absolutely zero inbound remote control server or remote shell created here. If you're on the InfoSec team, you can breathe a sigh of relief right now. This is a strictly controlled, outbound-only setup.
Section 1. Prepping the processing room. Let's talk about the physical environment.
You can't just plug 100 computers into a random room and start wiping drives. You need some really strict physical guardrails. Access to this processing room has to be locked down to authorized staff only. Inside, you'll need clearly defined zones: incoming, in-process, verified, and a quarantine area. Every single machine needs stable power, wired Ethernet, and a clear path to reach the console laptop on TCP port 8443. And I literally cannot emphasize this enough. If you find any computer under legal hold, involved in an investigation, or with questionable ownership, it bypasses this entire process and goes straight to quarantine. Wiping a legal hold computer is a massive liability, so physical segregation is your absolute first line of defense here.
Now let's talk about scale. The magic number here is 50. That's the default maximum concurrent jobs limit in DataDiscard. You might be wondering, why 50 when we have 100 computers? Well, while the system can easily display and manage 100 enrolled nodes, kicking off 100 highly destructive, resource-heavy jobs all at the exact same second can totally overwhelm your network switches, spike your console CPU, and just stretch your operators way too thin. Thanks to this built-in safety limit, we're going to process our 100-computer room in two very controlled, highly observable ways of 50.
Section 2. Configuring the central console. Let's look at the management settings.
Once you've got the CyVectors installers squared away, it's time to lock in some critical console settings. First up, your organization and facility info. These fields get permanently baked into your final evidence reports, so accuracy is completely non-negotiable. Next, we set up email notifications and RFC 5424 JSON syslog for standardized immutable event tracking. You can even hook this up to SolarWinds Observability SaaS to ingest those logs for some really nice centralized dashboards. Finally, you've got a local Olema RAG assistant. RAG just means Retrieval Augmented Generation. It basically uses an AI embedding model against the local user guide to help answer any contextual questions your operators might have. But just to be crystal clear here, this AI assistant is strictly for operational guidance. It cannot execute erasure jobs, and it definitely cannot reveal system secrets.
Inside the console, you've got to draw some very sharp lines between user roles. This isn't optional, it's a strict security requirement. An administrator is in charge of managing security settings and enrolling biometric authorizations. An operator is the one actually performing the authorized work and triggering the erasure jobs. And an auditor? Their access is entirely restricted to just reviewing the evidence and downloading the final reports. Separating these roles ensures a proper separation of duties, meaning literally no single person can authorize, execute, and blindly sign off on the destruction of data.
Section 3. Creating bootable erasure media. Let's get our offline tools ready.
So you're going to hear the term WinPE thrown around a lot in this process. It stands for Windows Pre-Installation Environment. Basically, it's a super lightweight version of Windows used mostly for deployment and recovery. We absolutely need it because you simply cannot securely wipe a Windows system disk while Windows is actively running on it.
Think about it. It'd be like trying to saw off the exact tree branch you're sitting on. WinPE lets us boot safely outside the primary OS, giving us an isolated, secure environment to run our signed worker and storage adapters to get the job done right.
Creating this media follows a very precise workflow. First, we use the console to format and build what we call a golden USB. This injects the WinPE image, those signed adapters, and embeds the console's LAN URL alongside its certificate fingerprint. Step 2, we verify the manifests and SHA-256 hashes just to guarantee the media hasn't been tampered with. Finally, we clone it. The console reads that golden USB into a protected cache and writes it out to blank drives. And since we're doing this in 2 waves of 50, we really only need 50 USBs, not 100. The best part? The console assigns a completely unique media identity file to every single cloned USB. That means they can be individually tracked in the inventory, which is going to save you from a massive auditing nightmare down the road.
Section 4. Connecting agents and disks. Time for endpoint connectivity.
Now what's really interesting here is how seamlessly the Windows agent handles the whole intake process. It totally saves your technicians from standing there manually typing out dozens of serial numbers. A tech just plugs in the USB, runs the agent as an administrator, and it automatically reads the adjacent media manifest. It connects outbound to the console, authenticates the TLS fingerprint, and instantly fires over an incredibly deep hardware and disk inventory. Once that computer pops up on the console, the operator's job is super straightforward. Just match the reported system details like serial numbers and host names directly to the physical asset tags on the actual machines in the room.
This brings us to the storage matrix. You really need to understand exactly what it is you're trying to erase. DataDiscard can inventory NVMe, SATA, USB, and RAID volumes, no problem. But operations are strictly gated based on what the hardware can actually do. For example, if you have empty 0-byte card readers, they're going to show up in the inventory, but you have to explicitly block them from selection so they don't cause failed job statuses. Also, if you're dealing with RAID or controller-presented SAN volumes, you're usually limited to a logical clear. Why? Because the underlying physical disks aren't directly exposed to the software. The RAID controller abstracts all of that.
Section 5. Executing secure erasure jobs. I actually want to slow our pacing down just a bit right here, because this is where we introduce highly destructive actions, and operational safety becomes absolutely paramount.
When you're picking an erasure profile, you have to definitively distinguish between a clear and a purge. Clear processes the entire addressable storage space using a software-level overwrite, but purge? That relies on much stronger device-native commands, like NVMe sanitize or a full cryptographic erase. Here's the kicker. A purge command literally cannot be claimed or executed unless the exact signed adapter and specific device qualifications are present. If the hardware doesn't natively support a true purge, the system will not just silently fall back to a clear and let you pretend it was a purge. That strict hardline enforcement is exactly what protects you from a massive compliance violation during an audit.
The execution flow also splits depending on the type of disk. If you're erasing a secondary, non-system disk, that can often be handled via live Windows execution right from the agent. But for Windows boot or system disks, that strictly requires WinPE offline execution. The agent writes a protected pending job handoff file to the USB, the computer restarts, boots into WinPE, and then the signed worker takes over to safely process that system drive completely outside of the OS.
So picture the room again. You've got 100 machines processing, cables everywhere, and irreversible data destruction on the line. We have to ask the single most critical safety question of this entire explainer. How do we prevent accidental erasure?
DataDiscard enforces a really strict dual-layer protection mechanism. It's basically the ultimate safety net for IT admins. First, over at the console, it requires biometric face authorization from an enrolled administrator. And yes, this includes liveness detection, so you have to blink or do randomized head turns to prove you aren't just holding up a printed photo. It's a proprietary control totally separate from standard Windows Hello. Second, and honestly, this is a huge relief. Even after the console sends out the signed job, the erasure doesn't just start. A technician standing physically at the endpoint has to review the exact disk scope on the screen and physically type in an exact local confirmation phrase. No erasure ever begins just because a job happened to arrive over the network.
Section 6. Generating verified compliance reports. Let's talk about your compliance evidence.
So, the crucial point is this. A successful job results in a production sanitized status, which generates a highly specific report bundle. You're getting a human-readable PDF, deep JSON evidence, a signed manifest, and a verification result.
All of these files are bound together using an unbreakable RSA PSS SH256 cryptographic signature. The math literally guarantees the authenticity. If anyone tries to alter even a single byte of that JSON evidence, say to fake a serial number or tweak a timestamp, the cryptographic signature verification will immediately fail.
Which brings us to a really essential compliance guardrail. The documentation is extremely clear on this. DataDiscard provides verifiable evidence of sanitization. It does not independently issue government or regulatory certification. Any compliance officer will tell you, these reports provide exceptional, cryptographically sound evidence to support your NIST SP 888, GDPR, or HIPAA documentation. But the software tool all by itself doesn't equal organizational compliance. That ultimately depends on your own internal InfoSec policies and how securely you handle this evidence.
And this brilliantly illustrates our entire workflow, coming together into one final operational checklist. You lock down the physical environment and the network. You format unique USB clones for perfect traceability. You physically inventory all 100 computers, run the agents, and match up your physical assets. You face authorize the scope, locally confirm the jobs to prevent accidents, use WinPE for the system disks, and finally, you retain that unbroken cryptographic report bundle before you even think about releasing hardware to the refurbisher.
We've just walked through securing 100 endpoints with absolute precision. I want to leave you, especially the IT admins and compliance folks tuning in today, with a final thought about your own workflows. Are your organization's hardware disposition claims actually backed by cryptographically verifiable evidence, or are you just operating on blind trust? Thanks for joining me for this explainer.